Hello and welcome to this brand new ArcGIS Pro tutorial. In this video, we have a problem to solve. Several people want to go to a football match at the stadium but don't have transportation to get there. To address this, the municipality has provided a bus that will pick up the registered passengers right at their doorsteps. So, in this video, I'll show you how to create an optimized route to pick up all the people from their homes in the fastest way possible. So, without much further ado, let's get to the video. Let's start by analyzing the data we'll be using. In our project, we've already imported two shapefiles, one for stops, which will represent bus stops, and another for lines, which corresponds to the road network. In the stops shapefile, the white marker indicates where the route will start, while the yellow marker represents the endpoint. We can start the video by opening the attribute tables of both shapefiles. Let's begin with the stops. We can clearly see that the first point corresponds to the start, while the last one is the finish. An important note: when performing this type of analysis, we need to ensure that the start point is at the beginning of the table and the last point is at the end. If this is not the case, we can always have these 2 points in separate shapefiles, as I will explain later in the video. The first step is to add a new field to the attribute table, which will be named minutes. This field will represent the average time a person takes to board the bus from the moment they arrive at the stop until the bus departs again. So, we simply add a new field of double type named minutes. We click on Save. Then we select all stops, clicking on Shift. Then right-click on Minutes, Calculate Field. For passenger boarding, we will assign an average time of 30 seconds per stop. Since we need to represent this in minutes, we input 50% of a minute, which is 0.5. Click Apply and OK. For the start point, we don't want any stop time, so we set it up to 0. And the same applies to the final stop. We can close the table, clear the selection, and now let's move on to analyzing the roads. From the symbology, we can quickly see that there are 2 unique values, one for streets classified as null and another with yes for the one-way attribute. The red roads represent one-way streets, and what we want is for these roads to be followed in the direction of the arrow, which corresponds to the direction in which the street was drawn. We will define this later, but if you want to learn more, I already have a video on my channel dedicated specifically to one-way streets in ArcGIS Pro. As we can see in the attribute table, when the road is two-way, the one-way field is empty. However, when the road is one-way, the one-way field is filled with yes. Another important aspect of these streets is the speed field, where all the roads have a maximum speed of 50. This will be used to calculate the time it takes to travel each road segment. I will click on Save Edits to be able to create a new field in this shapefile. We click on Add Field. We will name it Minutes as well. And the data type will be double. And then we can click on Save. Now we need to calculate the time it takes to travel each road segment based on the speed and length fields. Right-click on the Minutes field and select Calculate Field. Open parentheses. Shape length. We need to multiply with 60, since we need to convert hours to minutes. Close parentheses, and we divide, open parentheses, speed, and we multiply with 1000, since we also need to convert kilometers to meters. We close parentheses, click on Apply and then OK. And here we have the time it takes to travel each road segment in minutes based on a constant speed of 50 km per hour. Next, we will create a network dataset so that we can then perform a network analysis. To do this, I will close the table, click on View, Catalog pane. I already have my elements in a geodatabase. If you want to learn how to create a geodatabase in ArcGIS Pro, you can watch the video that is appearing in the top right corner. On top of the Feature Dataset, I will right click, select New, and then choose Network Dataset. I will name it Tutorial ND. And for the source feature class, I will make sure to select only the streets. For elevation fields, in this example, it's irrelevant since we will not be using vertical connection levels in the network. This applies to overpasses and bridges, but we can keep the elevation fields without any problem. After clicking Run, we now have our network dataset. However, since we will be modifying its properties, we need to remove it from our map. So I will remove it like this. On the tutorial_ND element inside our File Geodatabase, we'll right-click and select Properties. We will start by defining a travel mode in Travel Attributes. In this tab, I will click on the menu in the top right corner and select New. I will name it Bus. The type will be driving, length meters, and later we will create our time cost, which is not yet defined. Next, we will click on Cost. Then, in the menu, we select New. The name will be Time, unit set minutes, and data type will be double. Now we need to tell our network dataset where it should base the time in minutes. This will be the minutes field that we previously defined in the streets shapefile. So in evaluators for streets along, we select field script. Once again, I remind you that I already have a video on my channel explaining what streets along and streets against are. Double click on this tab, then click on the green button to open the code window. And in result, inside double exclamation marks, we write the name of the field where the time in minutes will be based. The name must be written exactly as it appears in the table. In my case, is uppercase letters. For streets against, we can leave the type as same as along, meaning it will also use the minutes field. Next, we go to restrictions to define one-way streets. Click on the menu. Choose New once again. For the name, I'll call it OneWay. Usage type to prohibited, since we are defining a direction in which the route can never proceed under any circumstances. And finally, in type, under the evaluators tab, we also change streets along from same as default to field script. We open the code window. For the result, first we set the name of the restriction, which is OneWay, and then inside parentheses and exclamation marks, we set the name of the field, which, if you remember correctly, is this one, OneWay in uppercase. Now we've reached a part that might cause some confusion. In the code block for streets against, we want to specify that in this direction all roads can be traveled. So we write def OneWay. Inside parentheses we write value, close the parentheses, add a colon, and then we write return false. To help you out, I will leave these expressions in the description of this video and in the first pinned comment. For streets against, we will also choose field script and open the code window. For the result, we define the same as before, so OneWay, and then inside parentheses and double exclamation marks, we type the name of the field. But the code block will be slightly different, since in this case we want to tell the software that when the OneWay field contains the word yes, that road segment cannot be traveled in the against direction. So we write def OneWay value, add a colon, if value double equals sign yes in quotes, add a colon, then return true, else return false. And it stays like this. To add these spaces, I'm pressing the Tab key. We click OK. We go back to travel modes, and now we can finally define the time cost for our network dataset. So we just need to select the time cost we created a few minutes ago. To finish, it's important not to forget this step. We need to check the restrictions we want to use, otherwise they won't be applied to the analysis. We have everything we need for our network dataset, so now let's click OK. Our network dataset is now almost ready to be used. The only step left is to build it. To do this, we right-click on it and select Build. Then click Run. Our network dataset is now built, so now let's perform the analysis to find the fastest route between 2 points while stopping at multiple locations along the way. Go to Analysis, Network Analysis, choose the second option, Route, find the shortest path between stops. In our table of contents, we can now see elements labeled Route. We click on Route to have this element selected, go to Route layer at the top, and we will import the stops into our route layer. The points are already on the map, but they are not yet in the route layer to be used in the analysis. Click on Import Stops. I will click on View and Catalog pane and drag and drop the stops into the input locations. And since we defined the stop time at each stop in the minutes field, which is half a minute, this is the stage where we need to match the field with this new layer. To do this, we click once on ATTR time, and in field name we select the field we create, minutes. Click OK. We now have our points in the order they were drawn. As I explained at the beginning of the video, it's important that the starting point is the first point in the table and the destination is the last one. Alternatively, we can have 3 separate shapefiles, one for the starting point, one for the stops, and one for the final destination. If we are using separate shapefiles, we need to be careful when importing stops. First we import the shapefile with the starting point, then we repeat the process for the intermediate stops, and finally we import the shapefile with the destination. We go back to route layer. The mode will be buzz, the only one we have. Sequence we need to change to preserve first and last stop, since we want to start on the number 1 and finish on the 33. And in the summation button, we need to check both available options. So for accumulate cost attributes, we define time and length. We have everything we need, so now we just need to click Run. Our network analysis is now complete, and as we can see, the one-way restrictions were properly respected, as we can see here from the point 1 to point 2. For example, the most obvious case, if there were no way restrictions, will be for the first stop to be at point 8. However, as we can see, that did not happen, which confirms that the restrictions were correctly applied. One thing we can quickly notice is that the system often forces U-turns, as seen at stop number 5. This is something that can also be controlled within the network dataset, so that might be an interesting topic to explore in future videos. Let's finish by taking a quick look at the attribute tables of the stops and the route. Let's start with the stops. We can quickly see the original sequence, the new sequence, and the time at which the bus will arrive at each stop. For example, at point 22, which is 25 in the sequence, we know that the bus will stop here at 21 minutes and approximately 30 seconds. So 21 minutes and 48 after the departure of the bus. If we now check the route table, we can see the distance, which is 9.5 kilometers, and the total time is almost 27 minutes. That's all for today. I hope you enjoy it. See you in the next video. Thank you for watching. If you like this type of content, don't forget to like, subscribe and comment what you want to learn next.